Okay, should we start? As usual, am I visible? Is the screen visible? Good evening, Vishwajit. Yes, good evening, Prem. Good evening, Sanika. So we have to start with regression today. I'm visible. Okay. Good evening, Vishraj. Fine. Okay. Yes, good evening, Akash. So let's start. We have seen correlation. Let's go to regression now. What is regression? Regression is predicting value of one variable. Okay, predicting value of one variable based on value of other variable. Okay, yes, good evening, Vaibhavi. So predicting value of one variable based on other variable using their correlation. Using their correlation. Okay. Okay, it means what? For example, let's say we have last 5 years rainfall and we have last 5 years rice production. Okay. Now we know that obviously rainfall and rice production are related to each other, correlated, right? Most probably uh, the relation will be high positive, right? So higher the higher the rainfall, higher the rice production, right? Most probably the correlation is going to be high positive. So based on that, if we have maybe 5 years or 10 years data of rice fall and rainfall and rice production, okay, rice fall nahi, rainfall and rice production, then maybe we can predict next year's. So if we have, let's say, maybe in next year we are predicting that rainfall will be 120, okay, then maybe we can try to predict how much will be rice production in next year based on that, based on their correlation. That is called as regression. The method that we use for regression is called as least squares method. Okay, so let's start with least squares method. Let's see why it is called as least squares method, and then let's see the formula. Now first of all, let's say we have two variables as rainfall and rice production. Now can you tell me which one is dependent on which one? Rainfall is dependent on rice or rice is dependent on rainfall? What is dependent on the other? Anyone? Can you tell me which one is dependent on which one? In chat, anyone? Can I say correct? Very good. Rice production is dependent on rain. So rice production is dependent on rainfall. It is not the other way around. Rainfall is not dependent on rice production. That means here we'll call rice production as dependent variable and rainfall as independent variable. So rice production is dependent on rainfall. So we'll call rice production as dependent, rainfall as independent. So if we are given next year's rainfall, then we can calculate next year's rice production using regression. It cannot be opposite. We cannot say next year rice production will be this much. That means rainfall will be this much. That makes no sense, right? Or it has some other names also, like this is dependent, this is independent. Let me put it in terms of x and y first. Let's say this is x and this is y. That means what is dependent on what? X is dependent on y or y is dependent on x? Here x is dependent on y or y is dependent on x? Anyone? Can I say x is dependent on y? Or yes, or we can say that y is independent, x is dependent, or we can say that y is predictor on the basis of which we are going to predict, and x is regression variable. That is the one which the one whose value we are going to find, or we can say that y is explanator. That is the one which explains, and x is explained variable. Okay, that is the one which we calculate. That is here x depends on y, or we call it regression of x on y. Okay, regression of x on y, that is x is dependent on y. If it is the other way around, we'll calculate regression of y on x. Regression of y on x means what? Y is dependent on x. Now understand very carefully. Let's take two cases, x on y and y on x. If we draw scatter diagram of the data, let's say we have a data of past 10 years x and past 10 years y. Let's say we draw scatter diagram of the data. Maybe it is looking something like this. So there seems to be positive correlation. Let me draw it here also again. Let's assume that it is same. Whatever. Assume that the two diagrams are same. Right. Now our objective in regression is what? Our objective is to find best fit line. Best fit line. Line of best fit. That is a line which fits this scatter diagram perfectly so that we can predict next value. Because now understand, here y is dependent on x. So if x increases, let's say right now when x is 100, let's say y is here 70. So now we have to predict if x becomes 110, y will become how much? Now based on this diagram itself, only this diagram, it is very difficult to predict. How can we know that next point is going to be where, right? So what we'll do is we'll try to find best fit line. Best fit line as in we'll try to find a line like this which passes through the points in such a manner that points in such a manner that sum of squares of errors is minimum. Okay, understand carefully. We draw a line in such a way that sum of squares of errors is minimum. What is errors? What is sum of squares? What is minimum? Let's understand. Let's focus on y on x only right now. So let's say in y on x, we have to predict y based on x, right? We have to predict y based on x. Now understand that these are the actual values of y. These points are actual values of y. So let's call them y. Whereas that line we have drawn is estimated value of y, right? Estimated y. We don't know, we know that the line is not exactly like the points, but we are saying that it is the best fit line. So it is estimated value of y. So we'll call it y hat. Hat, you have seen this in theoretical distributions also. Hat is used for estimated values. Now what we have to do is we have to minimize their distance. Okay, this is logical. Understand logically. Whatever is the distance between point and the line, like this, understand? On y-axis, obviously vertical distance, because we are calculating for y. So whatever is the distance between points and the line, total of that distance should be minimum. Total of that distance should be minimum. Why? Because the line needs to be best fit. So we have to minimize this. This is called as errors or residue. So we have to minimize this. But the problem is some of the values are positive, some are negative. So while minimizing, it might happen that there is 100 positive error and 100 negative error, which will give us 0, which is wrong, right? So what we'll do is we'll make this positive. How can we make this positive? Either we can take absolute value, okay, but we'll not do that, or we can take square. Hmm. Because square is a better measure. So that is why this method is called as least squares method. So in least squares method, we have to minimize error square, summation of error square. That is, we have to minimize summation of y minus y hat bracket square. Now in our class, we have also seen derivation of this. Okay, we have also seen derivation of the regression lines. I hope everyone remembers. Yeah, then to minimize this, we take derivative and then we equate it with 0 and everything. A lot of complicated procedure. And after that, we get a regression line. Okay, after that, we get a regression line. Right now, this is revision lecture, so let's directly see the regression line. When y is dependent on x, we are talking only about this right side case. We are not talking about this right now. So when y is dependent on x, the regression line is y is equal to a plus bx. Where a, good. Where, okay, let's see b first. Where b is called as regression coefficient. Regression coefficient, okay, of y on x. That is why we write it as byx. Okay, we write it as byx. And formula of byx is similar to formula of correlation coefficient. Okay, the numerator is same, n summation xy minus summation x summation y upon no square root n summation x square minus summation x bracket square. For y on x, x is in the denominator. Then we can get a as, we can rearrange this as y minus bx and just write y bar and x bar instead of y and x. That gives us a. So this is formula of b by x and this is formula of a. Understand it logically. You should always try to understand logic behind every formula. This gives us b by x and a. Okay, right now we are just revising, so that is okay. Let's try to apply this formula in some question. Let's try to apply this in some question to see if this works. There is alternative formula also using covariance, which we'll see later in properties. Right now, let's try to use this formula in some x and y question. Let's say we have been given x and y. Now understand what is exactly to be done in this. Let's say we have been given x and y. X values are 2, 3, 5, 6, 10. That's it. Y values are 12, 15, 14, 20, 23. Can you tell me it looks like there is what kind of correlation between x and y? Positive or negative? It looks like there is what kind of correlation between x and y? Positive or negative? Positive, right? Correct. Positive correlation. So if I ask question like this, find y. Okay, we are using y on x, right? So y is dependent on x. So find y if x is equal to 15. Okay, this is the question. Now if x is 15, then logically if positive correlation is there, then y's answer should be greater than 23, right? So let's check if we are getting some answer like that. Let's try. Now correct, Sukanya, Rishura, Sanika, correct. We want y if x is 15. So we need y on x. That is y is equal to a plus bx. We'll start with b. B means byx. What is formula of byx? We have just written here. Let me write once again for division. N summation xy minus summation x summation y upon this x should be taken in denominator. N summation x square minus summation x bracket square. Then can you try to calculate this? Find summation x and summation y first. Calculate. Just a second. Let me get calculator. Till then, you guys calculate it. Summation x is 26. We are going to need x bar also. So x bar is 5.2. Summation y is 84. So y bar is 16.8. Correct. Let's see if anyone can get byx. Fast. अब तक आना चाहिए था. We have seen in correlation how to calculate all this, right? So try. I am writing down every value for your reference. Don't write down all. Try to do it on calculator. Try to do as much as possible on calculator. I am writing values for your reference. Correct. Y bar summation y, that is correct. Correct. Check if everyone is getting byx. 1.3453. Correct. Good, Vishwajit. Acha. Okay, correct. Why Sanika? Fine. Then let's calculate A also. A is what? Just rearrange that line. Y bar minus bx bar. So that will be 16.8 minus 1.3453 into 5.2. Y bar minus b into x bar. So 1.3453 into 5 sorry into 5.2 m plus 16.8, sorry, m minus 16.8 m plus, sorry, it should be 9.8044. Correct, Sukanya, Akash, Rishraj, correct. Check if you are getting A also. Correct. Correct, Vishwajit. Has everyone got A? If yes, then it is easy to find the answer now. We have to find y if x is 15. We know that the line is y is equal to a plus bx. So we'll put x as 15 now. So y is equal to 9.8044 plus b, that is 1.3453 into x, which is 15. So answer to y should be what? Can you calculate? Is it coming to be 29.9839 something? Sanika Abbas. Sanika, check if you have done, if you have taken this b properly. You might have taken 1.4353. Check once. Let me know when you get the answer, so that we'll go to next one after this. Then we'll go to x and y. Correct, Vishwajit. Around 30, that is correct. Sanika, have you got the answer? Everyone let me know. Sukanya, Vaibhavi, Akash. 29.9839 is the correct answer. Around. Correct, Akash. Correct, Prem. Correct, good. Sanika, have you got the answer? If yes, let's proceed to X on Y. If anyone has any doubt at any point, ask me. Sanika, Sukanya, let me know. Till then, let's start with X on Y. Correct, good. Fine. Now X and Y will be exactly opposite. Now this is very important from MCQ point of view, that in X on Y, now since X is dependent on Y, we have to find X value, right? We have to find X value. So we will take horizontal distances between point and the line. Okay, there is one MCQ in exercise on this, right? For X on Y, we take horizontal distances, which is errors. So for X on Y, we will take horizontal distances. Remember that, horizontal distances. Fine. Then the line will be exactly opposite. X is equal to a plus by, where b will be bxy. So again, the only change will be numerator will be same because it contains both x and y. So n summation xy minus summation x summation y upon n summation y square minus summation y bracket square. And a will be just rearrangement, x bar minus by bar. Clear everyone till this point? Should I give an example? That's it. It is exactly opposite. Sanika, I hope you have got the previous answer. This is 34. Try to find x if y is equal to, try to find x if y is equal to 100. Before starting, can anyone logically tell me the answer should be greater than or less than what value? Before starting, logically, can someone tell me the answer should be greater than or less than which value? Around, approximately. Then you can start solving. Anyone? Anyone? Approximately the answer should be in what range? Below what value or above what value? No one? See, when y is 100, it seems like there is negative correlation, right? So when y is 100, can I say x is going to be even below 5, right? So the answer has to be below 5 in any case, right? Because when y is 100, even above 95, y has to be even below 5. So, x has to be even below 5. So the answer is going to be something below 5, that we know. Not less than 40, Sanika, right? See, when y is 100, then x is going to be something less than this, right? So less than 5. Understood? That is just like a cross check while solving a question that you can. That is okay, Sanika. You don't need to delete. Fine. So can you guys try to find bxy? So n summation xy minus summation x summation y upon n summation y square minus summation y bracket square. Try to find. Yes. Check if anyone gets bxy, let me know. Again, I am writing all the steps. You should not. This should be bxy. And a is, if we rearrange the line, x bar minus by bar. Akash, I am getting something different. Check once again. Let's see if anyone else gets answer like me or you. Then it will be confirmed which one is correct. This is going to be minus minus plus, so the a is coming to be 30.1. I'll wait till everyone gives their answers, so that I'll also understand whether my answer is correct. Anyone? Anyone else? Put your answer so that I'll also understand whether I have made any calculation mistake or Akash has made any calculation mistake. फास्ट अब तक आना चाहिए था. Correct. Negative, right? Akash, calculate. Try again. Because if two people like yesterday, now Vaibhav will argue, but like yesterday, if two people are getting same answer, then there is very less chance that it will be wrong. Correct. Question was find x if y is 100. So once you get this, you can try it. Not coming to be less than 5, but near 5, right? 6.364. It is very close to 5. Correct, Sanika Vishwajit. The final answer is coming to be close to 5. It should have been less than 5, but seems like the negative correlation is not that strong because of this 34. This 34 is come in between, right? That is why. Correct, Vishwajit. Correct, correct, Sanika Rishudas. Vaibhavi 6. Now you will type point. Now you will type something. Correct. Fine. I hope everyone has got these answers. This should have वापस. हाँ, correct. Fine, then let's proceed. So that was regression equations, basic. पहले ही जा रहा है. Okay. That was basic regression equations, bxy and byx. That is x on y and y on x. Fine. Now some It's okay. There are some questions in modules, some solved questions which are simple, like find x if y is given, find y if x is given, and so on. So before going to more advanced questions, we'll have to see properties. So let's see properties of bxy and byx and regression lines. I mean, in general, properties of regression lines. One of the very important properties is change of origin and scale. Now in modules, this property has been given in not in a good way. Okay, the way this property has been given in module is really difficult to understand. So let's see how to apply this property properly. Change of origin and scale. Understand very carefully. Let's say for x, we change its scale. Scale means multiplication by, let's say, p. Okay, now we'll not take a and b because we are already taking a and b. And let's say we change its origin by c. And we get a new variable u. Similarly, let's say for y, we change its scale by q and change its origin by d to get v. Then bvu, okay, is equal to byx into q by p. Similarly, buv is equal to bxy into p by q. That is, it changes by ratio of change of scale. Ratio of change of scale. Now in module, this is given in such complicated way that it is very difficult to understand. But if you have already studied as per module, then forget about this. Okay. If you have already studied as per module, then forget about this, because then you will get more confused. If you have skipped this part or not studied this part, then concentrate here. Let's try to solve one question according to this. Let's try. Let's take a question from module itself. Correlation and regression. I think there is one in solved, there is one in exercise also. So let's take solved one first. Solved one below properties. So here, yes. This solved one. Understand very carefully now. If relationship between two variables x and u, you can see by yourself also, page number 18.35. If relationship between two variables x and u is u plus 3x is equal to 10, that is, if we rearrange in standard form, u is equal to minus 3x plus 10, and between two other variables y and v is 2y plus 5v is equal to 25. So if you rearrange, v is equal to what? Minus 2 by 5y plus 25 by 5. Check carefully and then see if you get this. Let me know if everyone is with me till this. Are you with me till this? If yes, now understand, we are only concerned with change of scale. That is this and this. That's it. We are only concerned with change of scale. Now they are saying that the regression coefficient of y on x, that is byx, is known to be 0.8. Byx is known to be 0.8. So we want bvu then, okay, because y becomes v, right, and x becomes u. So we want bvu. So what to do then for bvu? We'll take byx 0.8 and then multiply by, first, by change of scale of y, that is by q, minus 2 by 5, and then we'll divide by change of scale of x, which is minus 3, q by p. That's it. If you remember in this form, it will be very easy. The way in which they have given, I feel, is very difficult to understand and very complicated. Can someone tell me what will be answer to this? Minus minus will be cancelled. 2 by 5 is 0.4. So the answer is 0.8 into 0.4 by 3. How much is it? 0.106 recurring. 0.106 will be the answer for BVU. Let me know if everyone has understood this. This is one of the very important parts of this chapter, because this is the part where everyone makes silly mistake. If you take Q by P or something like that, then like you're wrong, right? Understood? Okay, good. Has everyone got 0.106 recurring? Others, let me know fast. Yes, good. So I'll close this page. They are getting 8 by 75, which will be same. Check. 8 by 75 is also 0.106 recurring. So that is the same answer. Okay, if you see this, then I suggest don't remember it like this, because it is very complicated. You have to take change of scale in denominator. That is like not logical, right? I mean, why? Good. Okay, fine. Got it. Good. Fine. So we were at properties. Let's see other properties. Second property is, yes. Okay, good. Second property is another formula for this. What is another formula for this? For Byx, we can also write Byx as covariance of xy upon sigma square x. Covariance of xy upon sigma square x. But we know that, let me write it somewhere else. We know that R is equal to covariance of xy upon sigma x sigma y. That means covariance of xy will be equal to R into sigma x into sigma y. Covariance will be R sigma x sigma y. So if we come back here, that means Byx can also be written as R sigma x sigma y upon sigma square x. So we can cancel this sigma x with this square. So what remains is Byx is equal to R sigma y upon sigma x. This is an important formula, because there are some questions where if you use this formula you get answer in few seconds. Okay, so this is important, you have to remember this. So obviously in opposite way, Byx will be equal to Bxy will be equal to R sigma x upon sigma y. The easier way to remember is this: second variable comes in denominator. Always second variable comes in denominator. Here also in the original formula of Bxy, second variable comes in denominator. Because we are basing it on that, right? That is what is the denominator base. Is this clear to everyone? If yes, let's take questions on this also, then we'll go to third property. If this is clear, let's take some questions on this. Let me know if this is clear. Questions on this are like no. They are generally given in this way. Understand this. 18.17. Page number 18.32. The following data relates to mean and SD of prices of two shares in a stock. Okay. So for company A and B, let me write it here so that we can solve it properly. Clear? Good. Sukanya, Kranika, good. Okay. So for company A and company B, they have given mean and SD 44 and 5.6. Let me write it. 44 and 5.6, and for B it is 58 and 6.3. 58 and 6.3. Okay. Coefficient of correlation between the share prices is 0.48. That is They have given that R is equal to 0.48. Okay. Let's see what they ask. Find most likely price of share A corresponding to a price of 60 of share B. Instead of A and B, let's call it X and Y. So they want us to find only, let's see first part first. Most likely price of share A, that is X, that is we want to find X when Y is 60. So first we have to find X when Y is equal to 60. Can anyone tell me for this we need X on Y or Y on X? For this we need X on Y or Y on X. X is dependent on Y, right? Y is given. So we need X on Y. Line of X on Y is X is equal to A plus BY. That B is BXY. Now BXY can be found easily using R sigma X upon sigma Y. R is 0.48 into sigma X is 5.6 upon sigma Y is 6.3. So BXY will be directly found as 0.48 into 5.6 divided by 6.3. X on Y, that is correct. 0.426 recurring. A can be found by rearranging the line. This by we have to take here. So X bar minus by bar, that is given. X bar is 44 minus 0.426 recurring into Y bar is 58. So A comes to be what? A comes to, that is correct. B is correct, Sanika. Others, let me know your answers. This should be your A and B. Check. So you can literally get the answer within half a minute if you solve it fast. So you have to know this formula. This is very important. Has everyone got this? If yes, then find X when Y is 60. Correct. A is also correct, Sanika. Vishwajit correct. Sukanya correct. Good. Find X when Y is 60. Check if everyone is getting 44.8533 or close to that, approximately. That is also fine. Correct. Correct, Rishraj. Good. 44.85 or close to that. That is fine. Correct. Good. Others, let me know. And they have asked y when x is 50, but let's try to do something different. Can you try y when x is 40? Can you try to find y when x is 40? Let's see who gets the answer. Final answer directly. Directly final answer. That is correct. Prem, that is correct. Vishwajit, that is correct. Sanika, correct. Vishwajit, correct. 44.6. I think you rounded off too much, but that is okay. Anyway, we'll have options. Okay. You have to find y when x is 40. I'll do one thing. I'll turn off my screen. Okay, I'll turn off my screen. So I think screen is not visible now. And I'll also calculate here. You also calculate. Let's see if you get correct answers. That is correct, Vishraj. The previous one 44.88, that is correct. Let me know if anyone has got the answer. We want y when x is 40. Okay, let me get at least one correct answer, then I'll turn on the screen so that you can check the steps. Anyone? X is 40. Y when x is 40. Atharva. Yes, hi. जब सच में गाना गा रहा होता तो नहीं आता है अथर्व, और यहाँ पे आए हो यूट्यूब लेक्चर में और फिर वापस मुझे बोलोगे कि सर बुलाते नहीं हो. Very good, Akash. That is correct. 55.84. Check everyone if you have got 55.84. Everyone, check if you have got 64, 55.84. बहुत दिन बाद, correct. If everyone has got this, then we'll proceed to last 2-3 properties. Correct, Vishwajit? No, check steps. Those who have not got it, check each value, B, A and final answer. Oh, अच्छा. बोलो तो नेक्स्ट टाइम बोलो तो नक्की अथर्व. अथर्व अथर्व भी परफॉर्म करेगा फिर तबला उस वक्त. 50/8 पर करेक्ट. गुड. Let me know if everyone has got this. If yes, let's go to next property. Sukanya, Vaibhavi, Rishraj, have you got the answer? Correct. Let's see third property then. Those, if anyone is not getting it, let me know. Otherwise, let's go to third property. Now, third property is that bxy into byx gives us, understand, bxy into byx gives us r sigma x upon sigma y into r sigma y upon sigma x. So if we cancel this, r square, okay. So byx or bxy into byx gives us r square, which is called as coefficient of determination, which gives us explained variance. We have seen what this is in our class. Right now, just let's revise this. Explained variance upon total variance. Okay. So that is always between what 1 and 0 and 1, right? Correct, Sukanya? Hmm. Sometimes they ask what is percentage of explained variance. That means you have to find r square in percentage. Sometimes they ask what is percentage of unexplained variance. That means 1 minus r square, which is coefficient of non-determination. Non-determination, which is unexplained variance upon total variance. Right? Then this means bxy into byx ka square root is r, right? But we write it like this. If we write plus minus r. Why plus minus r? If understand, if byx and bxy both are negative, r will be negative. If both are positive, r will be positive. It is not possible that one is negative, other is positive, or this is positive, one is negative. This is not possible. If you are getting an answer like this, that means your answer is wrong. Okay, that will be a cross check to see if your answer is wrong. Okay, so it is not possible that one is positive and other is negative. Fine, Prem, that is correct. I hope everyone is clear till this point. Just let me know if you are clear. If not, that then also let me know. So that I am moving on to next property then. Fourth one. Intersection of regression lines. Intersection of regression lines is x bar comma y bar. That is, if we solve regression lines simultaneously, then the value of x and y that we get is x bar and y bar. We'll see a question on this. Clear? Okay. Because this is like the last important concept in this chapter, regression part. Okay. Clear? Good. Last fifth property then. If R is what? Correlation coefficient is equal to 0. That means there is no correlation. Then regression lines are perpendicular to each other. If R is 0, then regression lines are perpendicular to each other. Okay. And if R is equal to plus minus 1, that is perfect positive or perfect negative correlation, then regression lines are identical. Logically also this is correct, because you can see that if R is 0, that means the data is like this, then the line of byx where we minimize vertical distances, if that is like maybe this, then bxy is going to be like this. So they are always perpendicular in that case, one like this and one like this. But if R is plus minus 1, then they are identical, they are exactly same, because vertical and horizontal distances will be same in that case, because they are perfectly correlated, perfect positive correlation. Okay, that's it. That covers all the properties. We have to see one more question, last one, which covers these last 2 points. Question number 20, 18.20 on page 18.35. Concentrate everyone, 100% concentration. You have to see one more point in this, which is a very good one. Let me write this data there. For variables x and y, regression equations are given as, they have given regression equations as 7x minus 3y minus 18 is equal to 0. And second equation they have given as 4x minus y minus 11 is equal to 0. Now again, this is very important, because we don't know which one is x on y, which one is y on x. We have to calculate. This is very important how to do this. But first question is easy. First one is find arithmetic means of x and y. We have just seen that arithmetic means we have to solve this simultaneously. So can you try to find arithmetic means? Solve the lines simultaneously. Solve the lines simultaneously in any way that you want. So like we can take the second one as y is equal to 4x minus 11. Then we can put it in first one 7x minus 3 into 4x minus 11 minus 8. That gives us minus 5x is equal to minus 15. X should be equal to 3, and if we put 3 here, 4 into 3 minus 11, y should be equal to 1. Check if everyone is getting y1 and x3 fast. Simultaneously solving them, we can get y1 and x3. Okay, I hope everyone is getting this. Let me know. And in second one, they're asking identify the regression equation of y on x. So they're asking which one is y on x and which one is x on y. Which one is y on x, which one is x on y. Now understand carefully. For this we have to make assumption. Let's say our assumption 1 is yes, got it? Okay. Let's say our assumption 1 is that this is y on x. 3 and 1 correct. Let's say our assumption 1 is that y on x is first line 7x minus 3y is equal to 18, and x on y is obviously then the second line 4x minus y is equal to 11. How do we check whether this is correct now? Understand? If this is y on x, let's bring it in standard form. Y is equal to something. How can we do that? Let me write the steps if you want. So 3y is equal to 7x minus 18. Correct, 3 1 3 1, that is correct, good. So y will be equal to 7 by 3x minus 18 by 3. That means in this case byx will be, because we know that, right? We know that, just a second, we know that y is equal to a plus bx, right? That means this is b and this is a. So we have got b as byx as 7 by 3. And with second assumption, this is x on y, so let's rearrange it as x is equal to something. So it will be x is equal to 1 by 4y plus 11 by 4. That means we are getting bxy as 1 by 4. Tell me if everyone is with me till this point, because this is very important again. First is y on x, okay? Let's check. Now what we'll do is we'll multiply these two, byx into bxy. That gives us 7 by 3 into 1 by 4, that is 7 by 12. This 7 by 12 is less than 1, right? Because we know that byx into bxy is r square, and r square has to be between 0 and 1, right? And this is between 0 and 1. That means this answer is correct. Okay. If you get this answer as more than 1, then you have to take different assumption and check. If you get this answer as more than 1, then you have to take different assumption and check. Right now we got the answer, so that is okay. And if it happens that one of them comes to be negative and other comes to be positive, then you have to say the answer is neither. Okay, because this is not possible, right? That one will be negative and other will be positive, that is not possible. So if answer comes as one is negative, other is positive, you have to write that is wrong. Right means you have to tick the option that it is wrong. None of them is regression line. Okay, none of them is y on x, none of them is x on y. There is one such question in exercise, go through that. There is one such question in exercise which gives answer like this, and the answer to that is none of these, option D. Fine, clear? If yes, let's solve last two parts of that. Compute correlation coefficient between x and y. Okay, that we know, this is r square, right? R square is 7 by 12. So r is root of 7 by 12. So that is the answer. And next one is given variance of x is 9, find SD of y. Okay. We know variance of x, that is sigma square x is 9. That means sigma x is 3. We have to find sigma y. Now this is easy because we know that b yx or bxy anything, byx is equal to r sigma y upon sigma x. Byx we have 7 by 3 is equal to r. R also we have root of 7 by 12. Okay, whatever that is, let's calculate. Zero 0.7637 something into sigma y upon sigma x, which is 3. So let's rearrange this to get the answer. Check if you are getting this. And let me know if everyone has understood. Because regression is only this much. That's it. If you know these concepts and if you keep practicing, then regression is easy, not at all difficult. Correct, Vishwajit. Good. Everyone, do let me know on chat if you are clear with this. Because if yes, then we'll stop for today. Only this much. Yes, Vaibhavi. Yes, Vaibhavi. But obviously, you have to keep practicing. Okay, otherwise, I mean, there are a lot of formulas and lot of properties, right? In 1 hour lecture, we have seen a lot of properties today. So, like, you have to keep practicing. Correlation, regression will also come for around 4-5 marks, 3-4 marks. So that will be like bonus marks for you if you are clear with this. Clear? Good. I hope everyone knows about the section-wise weightage, which is available on Institute's website. Everyone must know about this section-wise weightage. So for maths, it is, for those who don't know, like this. So that 30 to 40% is out of 40 for time value of money. So for time value of money, 30 to 40%, that is 30 to 40% of 40 marks. So 12 to 16 marks are on time value of money only. Okay. Then 20 to 30, that means 8 to 10 marks are from first 3 chapters. Remaining 6 to 10 marks are from remaining chapters: APGP, permutations, sets, and derivatives integration. Logical reasoning, that is fine. If you see, blood relations and syllogisms have 30 to 40%, so it is again important. Statistics, now this is very important, observe. First 2 chapters have 45 to 50% weightage, which is, how much is 45% of 40? 18 to 20 marks are only on first 2 chapters: statistical description and central tendency dispersion. Okay. So that is very much. Then probability and theoretical distributions is 25 to 30%. Only correlation regression is 10 to 15%. That means only correlation regression is going to come for 4 to 6 marks. So again, that makes it important. And index numbers is again 4 to 6 marks. So like everything is important. So do it carefully, strategically. Anyone, any doubt? If not, let's stop for today. Yes. Okay, fine. Okay, then let's stop for today. Bye everyone. Good night. Tomorrow we'll most probably take theoretical distribution, but I'll confirm. I'll let me think and confirm. But most probably that one. Okay. So bye everyone. No doubt. Good. Bye. Good night.